Hello everybody, this is Eureka Math Module 4, Lesson 12. Today we will recognize lines of symmetry for given two-dimensional figures. We will also identify line symmetric figures and draw lines of symmetry. But first, let's talk about symmetry. So when we draw a line of symmetry or think about a line of symmetry, it is an imaginary line that divides a shape so that both sides are identical. So as in the objective, we will be talking about two-dimensional shapes. Those are flat shapes. So here's one flat two-dimensional shape, and let's think of its line of symmetry, an imaginary line that divides this shape so that both sides are identical. And we can draw one of those right down the middle. So this heart has a line of symmetry. It is symmetrical. Both sides around that line of symmetry are identical. If we were to fold that heart in half, all of the sides would match. So that is something we're going to think about today. But let's look at some examples here in the slideshow first. So let's look at this happy face. Is it symmetrical? Does it have a line of symmetry that we could draw so that both sides are identical? There's one. So it is. It is symmetrical when we have that line of symmetry. Let's try a letter. So is the letter A symmetrical? Can we draw a line of symmetry on the letter A? And we can vertically right there. So it is symmetrical. But we could try a different way. What if we drew the line horizontally? Now, is that a line of symmetry? It is not, because both sides the sides on either side of the A, in this case, will not fold up exactly. If we were to fold that, they are not identical on both sides of that line. So that is not a line of symmetry. Let's look at one more letter. Is the letter J symmetrical? Can we draw a line of symmetry anywhere on the letter J? So this way, no. This way, no. We could try, but I have a feeling that if we keep going, we will not find a place where it is symmetrical, where both sides are identical on the sides of that of a line of symmetry. So I would say the J is not symmetrical. So those are just some examples of shapes on the slides. We're going to look for symmetry by folding paper shape. So I'm going to scoot over to my document camera, and then we'll come back to the slideshow to talk about what we found. So here we are. We have a rectangle. I have a rectangular piece of paper here, and I'm going to try to fold it so that I can find lines of symmetry. So the first way I want to go, and just as a reminder, when we're folding paper, our line of symmetry has to be folded so that both sides of it match up perfectly. So let's try to match the sides up perfectly to find the line of symmetry. So I'm going to fold this one in half. So when we're looking for line symmetry, we are trying to fold our shapes in half. So here, I did find one line of symmetry, and I'm going to use normally lines of symmetry are imaginary, but we're going to draw them. So I'm just going to draw a line right there. So I folded this paper in half and found that it is symmetrical. I'm going to fold it the other way in half to see if it is also symmetrical. So I find that when I fold it that way, these two sides are, scoot that up a little so you can see it. These two sides are also the same. When I fold it, the corners, the sides, they match up perfectly. So I have found two lines of symmetry here. I'm going to try a diagonal line. So let me just shift my document camera so you can see my rectangle is a bit big. So if I folded it this way, so no, that's not going to work. And if I fold it this way, I'm not folding it in half. I could probably keep trying, but I have to say, I think those are the only ways. So with a rectangle, we have two different lines of symmetry. Let's try a square. So here's my square. I'm also going to do the same thing. I'm going to fold it in half. And I found one line of symmetry that way because when I fold it, all the sides and corners line up. I'm going to fold it the other way. I fold it that way. The sides and corners line up. So I'm going to go ahead. I found two lines of symmetry, very much like the ones in the rectangle. So I'm just going to draw those. Okay. I'm going to try diagonal like I did with the rectangle. And I have a feeling I'm going to find more. There's something about having the square have all the same sides, the same length, that I think makes it easier. So there, if I fold it this way, you see all the sides and corners match up perfectly. And if I do it the other way, I see that this matches up perfectly. So I'm going to go ahead and draw those two more lines of symmetry that I found. There. And I am not drawing these perfectly, but I'm trying my best. There. So I found 1, 2, 3, 4 lines of symmetry in a square. We're going to try a few more shapes. Now, of course, if you have paper at home and want to cut out shapes, you are welcome to explore and find different lines of symmetry. So here I have a parallelogram. A parallelogram has two sets of parallel lines. It's a rectangle does too, but a rectangle is a type of parallelogram, but a rectangle has 4 right angles. A parallelogram has 2 acute angles and 2 obtuse angles. But what it has in common with a rectangle is these lines are parallel and these lines are parallel. The sides, these two sides are the same length, and these two sides are the same length. So let's try our parallelogram. I'm going to try folding it this way first. So take a look. That did not fold so that each of the sides matched up perfectly. If you look at my fold there, the sides, and I'm going to make that darker for you guys so you can see. So when I folded it this way, those sides are not identical. They're the same size, but they're not identical to each other. So let's fold it this way. Now, if I folded it in half this way, I can tell right away that the sides and corners do not match up with each other. So that's not a line of symmetry. If I tried to fold it diagonal, I'm not finding any lines of symmetry. So the parallelogram, we did not find any lines of symmetry. Okay, and we'll go over these at the end or a little bit later. So this is a shape that is much like a parallelogram. It has these two sides that are parallel to each other and these two sides. So like a rectangle, like a square, like a parallelogram, it has two sides that are parallel and another two sides that are parallel. This looks like a parallelogram because it does not have right angles. I see that it has 2 acute angles and 2 obtuse angles. What is special about this rhombus is that all the sides are the same length. So it's kind of like a square, but a square that has kind of been moved over to the side, kind of tilted to the side, so it no longer has its right angles. So let's go ahead and see if we can find lines of symmetry in this rhombus. Remember, in the rectangle, we found 2, and then in the square, we found more. So I wonder if we will find more than the 0 we found in the parallelogram. So let's try. So I'm going to try this way. So if I fold it this way, the lines and corners do not match up. So that's not a line of symmetry. Let's try it this way. Again, my sides and corners do not line up. So that's not a line of symmetry. Let's try diagonal. So wait a second. I did it this way, and I did find a way to match up the corners and the sides. So that is a line of symmetry. So I'm going to draw that for you to see. So there's a line of symmetry in my rhombus that way. And I'm going to try it this way. So take a look. I think I found another one. So there, if I fold it this way, I found a way to match up those sides and corners. And if I look at it, both sides are identical around this line of symmetry. There you go. So I have found 2 lines of symmetry in my rhombus. All right, we have one last shape to try out. Our last 2-dimensional or flat shape is a circle. Our circle has no angles. Our circle has no lines. So I wonder if we'll find any lines of symmetry. Let's try. So let's go ahead. I'm going to fold it in half because that's the only way we can. And already I found a line of symmetry. So I'm going to trace that. You can see both sides are identical. They are the same on either side of that line of symmetry. I'm going to fold it this way. And I found another one. It seems very easy on this circle to find a line of symmetry. So I'm noticing that whenever I fold it in half, I find a line of symmetry. I'm going to fold it in half this way. Again, all of it matches up with the other side. I'm going to draw that. Let's try just one more time to see, because I think I have a theory. I think you're thinking the same. Let's say I'm folding it that way. And again, everything matches up. I think I can keep going forever and ever. And what does that mean? What does it mean when you can keep going forever and ever? Because even if I turned it a little bit and put it and fold it in half, I would find a line of symmetry. I would find it here. I would open it up, turn it a little bit. I would find it here. So I would say that a circle has an infinite amount of lines of symmetry. And I think that is because it has no corners and it has no sides. So because of that, you can keep finding lines of symmetry. All right, we're going to return to the slideshow, talk a little bit about what we discovered. Okay, so now we're back after we've done some folding. And let's just go over what we found. So the rectangle was symmetrical in 2 ways. It had 2 lines of symmetry. So a rectangle has 2 lines of symmetry. The square was symmetrical in more ways. It had more lines of symmetry. So we folded it and found more ways, 4 ways, I think. The parallelogram had no lines of symmetry. The rhombus had 2 lines of symmetry. Oh, the trapezoid. We actually did not get to the trapezoid, but if we had a trapezoid, it has 1 line of symmetry, only there in the middle, not the other way. So it's symmetrical 1 way. I apologize for not getting to that trapezoid. And then our circle. Now, our circle had infinite lines of symmetry. If we kept going, we could find all of them. It would take us an infinite amount of time. So that's what we learned. Let's head over to that problem set. We'll go over a few together, and then you can do the rest on your own. There's the problem set. Let me get my problem set out. And here's my problem set. All right, so let's start. It says circle the figures that have a correct line of symmetry. So just as a reminder, guys, a line of symmetry okay, when folding a shape along that line, it will match up perfectly, or the sides will match up perfectly. So right now these are pictures so that you can't actually fold them, but you're going to imagine folding them. Another way to look at it is if both sides are exactly the same, identical on both sides of the line. So let's do the A together. A, that line is through the middle, that line of symmetry. If I folded it, those all would match up. They sure look the same to me. I'm going to circle A. For B, if I folded it along that line, pretty sure that would match up. I'm going to circle that. Take a look at C. C, that's a little bit smaller on that side than that. I'm not going to circle that. And finally, let's look at this rainbow shape. If I folded that rainbow shape along that line, it would match up. Okay. So for 2, find and draw all the lines of symmetry for the following figures. Write the number of lines of symmetry that you found in the blank underneath the shape. I'm going to start with A. This is a trapezoid that we skipped over accidentally earlier. So if you recall the line of symmetry, the trapezoid had one line of symmetry. I'm going to use a straight edge. If you have one, you should use it too. And I'm going to draw a dotted line there. It's not perfect, but I do know if I moved it over, it would be perfect. That trapezoid has one. What about, let's skip over to E. I'm going to let you go ahead and do the rest on your own. You'll just experiment, draw some lines, and see how many lines are lines of symmetry. How many lines where if you folded the shape along that line, it would match up perfectly. Okay, let's move forward to 3. Okay, we have some shapes here. Half of each figure below has been drawn. Use the line of symmetry represented by the dashed line to complete each figure. So there is a reason why they have given you grid paper to use. Now, remember, here's our line of symmetry, and I'm going to highlight that for this one. You are going to draw the other side of the figure, but you have to make sure it's exactly the same. So I would count up how many boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I have 18 squares here. I should also have 18 squares here. I'm going to use my straight edge. Excuse me. And there it is. I'm going to make sure it looks the same, but I'm just going to make sure it has the same. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. All right. For C, okay, I'm going to let you go and continue on your own. Draw the identical shapes on either side. Use the grid paper to help you. And finally, make sure you do the last question here. How many lines of symmetry does the figure have? You might want to go back to the slideshow to find out. So I'm going to head back over to the slideshow so that you can complete your work and check it. And here we are back at the slideshow with the problem set answers. If you haven't completed the problem set, pause here and then return when you finish and check your answers. So here are the answers to number 1 and 2. If you forgot some of the lines of symmetry, make sure you add them to your picture. Make sure your pictures, your figures are the same on each side of that line of symmetry. And finally, for number 4, it says, the answer here says there are too many lines of symmetry to count. There are an infinite number. No matter where you fold it in half, it would work. And that is the end of our lesson. I thought this was fun. I will see you in lesson 13.